Hi, my name is Elaine Bastismo. So this video I will discuss about the overview of electrochemistry method analysis. So this is the introduction of electrochemical method analysis. So electrochemistry is a branch of chemistry concerned with the interaction of electrical and chemical effects. It is a large part of this field deals with the study of chemical changes caused by the passage of an electrical current and the production of electrical energy by chemical reaction. It is named electrochemistry because it originated from the study of the movement of electrons in an oxidation reduction reaction. So electrochemical methods are analytical techniques that use a measurement of potential charge or a current to determine an analyte concentration or to characterize an analyte chemical reactivity. It is a qualitative and quantitative methods of analysis based on electrochemical phenomena occurring within a medium or at the phase boundary and related to changes in the structure, chemical composition, or concentration of the compound being analyzed. These methods are divided into 5 major groups. The first one is potentiometry, and the third one is voltammetry, third one is colorimetry, and the fourth conductometry, and the last one is a dielectrometry. So application of obtaining thermodynamic data about a reaction. To generate an unstable intermediate such as radical ion and study its rate of decay or it is a spectroscopic properties. And number 3, they use to analyze a solution for trace amount of metal ions or organic species. And the last one is the electrochemical properties of the system themselves are of primary interest, for example, in the design of a new power source or for the electrochemical methods have been developed. So, type of electrochemical techniques. So, they have 2 types of electrochemical techniques. First is a black techniques or bulk techniques. Interfacial techniques. So, the bulk techniques, in which we measure a property of the solution in the electrochemical cell. An example is the measurement of a solution conductivity, which is proportional to the total concentration of dissolved ions. So, interfacial techniques in which the potential charge or current depends on the spaces present at the interface between an electrode and the solution in which it's set. An example is the determination of pH using a pH electrode. So, despite the difference in instrumentation, all electrochemical techniques shared several common features. First, the electrode. The electrode is a potential determines the analyte form of an electrode surface. So, the second, the concentration of analyte at the electrode's surface may not be the same as its concentration in bulk solution. Third is a current is a measure of the rate of the analyte, oxidation, reduction. And the fourth one is we cannot simultaneously control current and potential. So, interfacial electrochemical techniques. So, the interfacial electrochemical techniques is divided into static techniques and dynamic techniques. So, static techniques, the current is not passed through the analyte solution. Potentiometry in which we measure the potential of an electrochemical cell under static conditions, is one of the most important quantitative electrochemical methods. So, dynamic techniques in which we allow current to flow through the analyte solution. It comprises the largest group of interfacial electrochemical techniques, or coulometry, in which we measure current as a function of time, amperometry, and voltammetry, in which we measure current as a function of a fixed or variable potential. So, these are the family tree highlighting a number of interfacial electrochemical techniques. So, the specific techniques are shown in red color. It is a specific techniques. While the blue one, experimental, it's called experimental condition. And the green one is analytical signals. For example, this one, static techniques and dynamic techniques, it is an experimental condition. So these are potentiometry, control current coulometry, this amperometry, control potentiometry. So this called as a specific techniques. So while this one, measure A, this one is a measure A, measure I versus T, measure I versus T. This one is a analytical signal. So, controlling and measuring current and potential. We cannot simultaneously control both current and potential. If we choose to control the potential, then we must accept the resulting current, and we must accept the resulting potential if we choose to control the current. So the second electrode, which we call the counter electrode, completes an electrical circuit and provides a reference potential against which we measure the working electrode's potential. Ideally, the counter electrode potential remains constant so that we can assign to working electrode any change in the overall cell potential. So electrochemical measurements are made in an electrochemical cell consisting of two or more electrodes, and the electronic circuitry for controlling and measuring the current and the potential. The simplest electrochemical cell uses two electrodes. The potential of one electrode is sensitive to the analyze concentration and is called the working electrode or the indicator electrode. If the counter electrode's potential is not constant, we replace it with two electrodes, a reference electrode whose potential remains constant, and an auxiliary electrode that completes the electrical circuit. Because we cannot simultaneously control the current and the potential, there are only three basic experimental design. So first is measure the potential when the current is zero. The second, measure the potential while controlling the current. The third one is measure the current while controlling the potential. So each of these experimental design relies on Ohm's law, which states that a current I passing through an electrical circuit of resistance, so R generates a potential of A. So this one, A equals IR. So each of these experimental designs uses a different type of instrument. So type of electrochemical methods. They have four. First is a potentiometry methods. It measures the potential of a solution between two electrodes. The potential is then related to the concentration of one or more analytes. The cell structures used is often referred to as an electrode even though it actually contains two electrodes, an indicator electrode and a reference electrode. So potentiometry usually uses electrodes made selectively sensitive to the ion of interest, such as fluoride selective electrode rather. The most common potentiometric electrode is the glass membrane electrode used in a pH meter. So for the second type of electrochemical methods is a voltammetry method. Is based on the applies as constant or varying potential at an electrode surface and measures the resulting current with a three electrode system. So voltammetry, with its variety of methods, constitutes the largest group of electrochemical methods of analysis and is commonly used for the determination of compounds in solution. For example, the polarography and amperometry. So, colorimetry methods, based on the measurement of the amount of material deposited on an electrode in the course of an electrochemical reaction in accordance with Faraday's law. A distinction is made between the colorimetry at constant potential and colorimetry and constant current. Colorimetry uses applied current or potential to completely convert an analyte from one oxidation state to another. In this experiment, the total current passed is measured directly or indirectly to determine the number of electrons passed. So knowing the number of electrons passed can indicate the concentration of the analyte or when the concentration is known. So the number of electrons transferred in the redox reaction. So the last one is the conductometry methods, in which the electrical conductivity of electrolytes, aqueous or unaqueous solution, colloid system and solids, is measured, and it is based on the change in the concentration of a compound or the chemical composition of a medium in the interelec- inter interelectrode space. Interelectrode space. So these are all the overview of electrochemical methods analysis. So this all about my reports, and thank you. And that's all.